we will give at the end of the project a deliverable with all the parameters of the configurations and the ways of future optimization of that configurations. Basically, right now, at the last versions, we have these 4 toroids that can be actually now launched with the SLS block 1. They have all the requirements to be put inside that launcher, so meaning that the diameter of each toroid is about 3 meters and the length of the toroid is maximum 7 meters. The overall weight of all the structure, so I mean all the toroids and the mechanical structure and the quantum protection system, cryogenic system, etc., with the contingency calculated and we have a large margin of the contingency because we wanted to be conservative. Right now we are at 60 tons, and with the 60 tons of materials we are able to reduce over half the effective dose astronauts receive, meaning that actually the spectra is reduced more than a half, but due to some effects, due to very high energy particles, we still have some residual doses. In future optimizations that we would like actually to develop, and not with this project because we are at the end, but in future projects, I think we can reach a better dose reduction and make this active shielding able to reduce the dose to a third or a fourth of the total dose astronauts can receive. In these ways, we can really think that active shielding is a solution for interplanetary missions or manned missions in this space.
Okay, thank you. Second question: do we know any parallel research overseas in the United States?
Yes, there is a research by NASA. NASA designed a different system, a solenoidal system, where the habitat is put inside the magnets or a series of magnets. We have a deep discussion with them. Their system doesn't work very well. The reason is that if you put too much materials around an habitat, you produce neutrons that, since they cannot be shielded by magnetic field or by passive materials, they hit astronauts and produces a lot of damages in the cells. So it was actually also our problem at the beginning of the project with the old configuration we examined before. It took about 1 year and a half to understand why we couldn't achieve very good results with something that in principle could work very well. Now we understood why. We should distribute the materials not homogeneously around the habitat, but in specific ways in order to limit the angles to which particles can reach materials. And we did it with the pumping configurations. The NASA project actually didn't give a good result, and so they are not satisfied with that. In comparison with NASA, they couldn't achieve our dose reduction, and actually they reduced about 20% the dose. We instead reduce about 50%.
Thank you and congratulations. You would achieve.
Thank you very much.
You invented the pumping configuration, and now you have to explain to everybody why this is a strange name.
Absolutely. This name, I don't know if we have a slide, but maybe with your slides. The magnetic field lines of the pumping configurations are very similar to a pumping, basically, because the 4 toroids that we have are linked together magnetically, and they design a sort of big shape with 4 lobes that reminds us a pumpkin, and that's why it's called pumpkin configuration.